enough waiting. Okay. So before going to your characteristics, we'll see some terms like amplitude, amplitude means maximum displacement. Now, when we draw one curve, so what is the maximum displacement it can go up and down? That is your amplitude. This is the this is your wavelength. This is one oscillation. Here, it starts from here, one cycle, that is one oscillation. To complete one cycle, how much time required? And then how much frequency it has. So there is frequency and time period and all that. We'll see all those things. Okay, so let's write here. So maximum displacement of oscillation or oscillating, let's write here, oscillating body or particle from mean position. So how much high it can go and how much low it can go. For that, how much time required or time it takes, that is time period. So time taken to complete one oscillating or oscillation. So we'll denote this as a T, this will denote it as A, then frequency. So
It
in
is number
frequency,
of oscillations
yeah,
in a second.
exactly. This was how much time it was taking here and how much time will, how much oscillation will be there in 1 second. Number of oscillation in 1 second. That is frequency or F or V. Okay, 1 by T. Okay, then let's talk about this units. Amplitude units, maximum displacement. What will be the unit of this maximum displacement? Yes. What will be the unit of this maximum displacement? No answer? Okay, then I'll answer this. That is meter, time period, second. Now tell me about frequency.
For hertz, second inverse, cycle per
Yeah,
seconds.
second inverse or cycle per second or hertz or radians per second. When we are talking about radians per second, it will become angular form. So let's write this one in new column. That is angular frequency, omega. Same thing. It's oscillating only. 2 pi f or 2 pi by t. Now 2 pi equals to 360. So pi equals to 360 by 2. So pi equals to 180. So conversion of pi and degree. 1 degree equals to pi by 180. Or 1 radians equals to 180 by pi. These things we need to understand and remember. Okay. Make a note and fix in mind these things. And even if you don't remember this one, at least you should know, you should remember that 2 pi equals to 360. Even I don't need to remember because I know this 2 pi equals to 360. That's it. It's more than enough. We don't want to remember so many things. Now, next is your phase. You guys understood this thing? These terms?
Yes, sir.
Other two? Okay. Next is your phase. Means it is just one more like this. These are some parameters. So this is one more parameter of it, of a wave, where like it will show the particular position of like a particle. Where is this particle exactly located? So this shows position of particle from its mean position. So if we take example, if a time period t equals to 0, that means that particle is at initial stage or phase. Or other way of saying this as a epoch. E. Okay. So if you see here, see terms like this, don't get confused. This is just a term for initial phase, that is epoch. Epoch. Now position will be given by omega t, as we saw here, time period. Then its phase will be just added there. So total angle will say total phase angle. It is omega t plus phase angle. Omega t plus phase angle is the total angle. See just once again, and any doubt in this some initial terms, ask. So we can go to some properties or characteristics. We'll see that. See that? Any doubt? Check. Done. Okay, then we'll go on next thing. No doubt till here, right? Basic doubts, anything from these terms and all that? All terms clear. But this will be required when we study characteristics and all that formulas. Samhita, Aditi, Madhusudan. Okay, then let's go. Characteristics. A SH M. Displacement. So displacement will be given by y equals to a sine omega t plus phi. Now in this one, remember that this is your amplitude. So this is your angular frequency. And this is your total phase. And this is your phase angle. Phi is your phase angle. So I will draw this sine wave. Sine wave starts from 0, one positive cycle, one negative cycle. We'll just draw this much. It will go longer, but we'll just draw this much. So this is displacement. Here it is. Time period or time. This point is 0, 0. Amplitude A. So here it is 0, then this will be total time t. If this is t, then this will be t by 2. If it is t by 2, then this will be t by 4. And this will be 3t by 4. So here, if we consider this is minus a. So this is your displacement. Now second, velocity. This is a velocity. So velocity, for getting velocity, we need to know dx by dt, means dy by dt. So if we differentiate this one, a will be constant, sine will become cos omega t plus 5 cos theta, and inside there is omega t. So omega will be outside. And a cos omega t plus 5. So this will be your displacement, sorry, velocity. So or else we can write here v, velocity v equals to omega under root a square minus y square. Amplitude of wave minus displacement. So in this one, if or at y equals to 0 means initial condition of that displacement, when the displacement is 0, displacement is 0 means at mean position. Vmax equals to 0 and omega. So this whole term will become 1. So we will left with Vmax equals to omega A or A omega. You can draw a graph for that. It starts from 1, means it will be cos curve. We can see here, cosine starts from 1, sine starts from 0. So this will be your half cycle t by 2. So this will be your t by 4, and this will be your 3t by 4. This is velocity here, and this is time. Next is your acceleration, number 3. Just a second. Okay. Yeah. So next is your acceleration. So for acceleration, what we need? dv by dt. So if you differentiate this equation again, so this will become A minus will be there, omega square, and cos will become minus sine omega t plus phi. So minus I already wrote. So A equals to, this is equals to, where is our displacement? A sine omega t. So if I remove A sine omega t, will be equals to y. So minus a y. Sorry, omega square, right? Omega square y. This is our acceleration. So same as y, but just opposite sign. So if we draw this graph again for acceleration, so at y equals to a, that is extreme position. So your graph will be negative, positive. This is t, one cycle, again t by 4, t by 2, and 3t by 4. Same thing. Here, acceleration. Let's go next. Have taken?
Yes, sir.
Okay. What about other two? Samhita? I think so. Internet is a mess today. Okay. Then let's finish this energy. What's your next class timing? You didn't mention. Maybe. See. Okay. Energy in simple harmonic motion. Now, energy formula, as you know, half mv square. So when we talk about V, so what we need here, where is everything? Yeah, A and Y. Just now we wrote. So we can substitute this one over, that's it. So let's talk about first kinetic energy. First one, kinetic energy. So when we talk about kinetic energy, that means one thing should come in mind, that is, what is kinetic energy? Anyone? No one? Okay, I can't keep waiting.
Sir, it's the energy
Yeah,
the body possesses when it moves or it is in a motion.
perfect. So we can say by virtue of its
Motion.
motion. Motion. That's it. Yeah, this is more than enough so that we can make it half mv square. So half m omega square a square minus y square, because under root will get cancelled over. That's it. Nothing much here. And potential energy, it's about displacement from mean position. So that is also PE equals to half ky square. So half m omega square y square. So total energy if we combine both, if we add ke plus pe, we'll get half m omega square a square y minus y square, and this one. So y square and y square will get cancelled. This term will get cancelled because they are equal. So we are left with only a. So I'll write finally 1 by 2 m omega square a square, or 1 by 2 ka square. So if we draw curve for both, so it goes positive as well as negative ways. Both. This is energy line. This is your displacement. Okay. So this gives you potential energy, and this is your kinetic energy. So this curve will give you total energy. Combination of both. Come on, make a note of it.
Sir, what is y square? Y square is velocity.
No, that is displacement.
Oh,
Y is displacement here.
Answer.
Okay. What about the two?
So, sir, for potential energy, A becomes zero, right? That's why it's half
Yeah,
m omega square y square.
there we don't have any amplitude there. We have displacement.
Yeah.
Okay. So in short, what we saw there, sine curve is for displacement, velocity curve will be a cosine curve, and acceleration will be negative sine curve. What else? Then combination of both energy, you can see here. So if you remember this curve, it will be good. So we saw first x displacement y equals to a sine omega t. So there sine curve. With that, if we differentiated, we got it as cosine curve. Then again we differentiated, we got sine curve, but negative. Then we substituted those values, we got energy. So I'll give you some questions as a homework today. You can try those. Like some, not all the questions, I'll just give some easy questions first. Then I'll solve some difficult question in class. Tomorrow we can do that questions. Then next, left with some machines we'll see. And oscillation, force and damp. Some systems we'll see and force and damp oscillation. That's it. Then we'll go for waves. That see wave things we already studied in like dual nature. So that same thing, but in some just for waves we'll discuss. Not wave optics or wave particles or nothing like that. Just a wave. What is a wave motion? That's it. Like these are some small chapters only, but still that is important. Okay, guys. Then let's see tomorrow. And try to keep joining early. Okay. Because next class onwards, I'll start 7 o'clock itself. The first student join, I'll start the class.
Okay, sir.
Yeah, because I don't want to waste 10 minutes.
Okay, sir.
Yeah, okay. Bye-bye, everyone.
Bye, sir.
Bye-bye.